Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic is binomial distribution. This lecture includes definition of binomial distribution, derivation of mean of binomial distribution, and the derivation of variance of binomial distribution and recurrence relation of binomial distribution. First, in this lecture, what is binomial distribution? That is, some theoretical distributions in which the variates are distributed as per some definite law, which can be expressed mathematically. That is, the theoretical distribution obeying mathematical law, they are expressed. These theoretical distributions, they are nothing but mathematical models. These mathematical models, the results are executed by using, that is, by computing the software. That's what it is written here. A theoretical distribution is the frequency distribution of a certain event in which frequencies are obtained by mathematical computation. Now, this theoretical distribution, which is divided into discrete theoretical distribution and continuous theoretical distribution. Under discrete theoretical distribution, there are again two types are there. They are binomial distribution and Poisson distribution. Whereas coming to the picture of continuous theoretical distribution, normal distribution is following. Now, in this video lecture, we are going to discuss about the binomial distribution, which obeys some mathematical law, and the binomial distribution formula is derived. Definition of binomial distribution: a random variable x. So the random variable x, suppose if we have a coin in our hand, only one coin, then we know it, the output is h t. The two possibilities only. If we toss a coin, these are the two possibilities of outcomes or sample points will come out. But if we want our target, our expected one is head. The same if you are getting, after tossing, we got success. If you didn't get, then failure. Now, this head and tail, these outcomes are converted into real numbers, that is 0, 1. So my expectation is head. If I get, the head is connected to the real number 1. If I'm not getting, so not getting, that means I'm getting tail. So the not getting head, it is connected to tail. So head and tail, the sample points, they are connected to real numbers with the help of random variable. So this is the job which is done by the random variable capital X. Otherwise, it is called as real valued function also. So which has a binomial distribution if it assumes only non-negative values, and its probability density function, which is given by probability of capital X equal to R, it's nothing but P of R equal to NCR P power R Q power N minus R. The R is taking the value from 0 to N. Q is nothing but 1 minus P, because P plus Q equal to 1. Always the total probability is 1. P stands for probability of success. Q stands for, or Q represents probability of failure. So the probability of success plus probability of failure, which is equal to 1, from which we derived what is Q. Q is nothing but 1 minus P. Now, in this notation, P is playing the role of probability of success, Q is playing the role of probability of failure, and whereas this N, the number of trials. Suppose if we have a coin, how many times we are going to toss? If we have a die, how many times we are going to throw? Otherwise, the manufacturers producing the product, total number of products, how much the manufacturer produced. So the total number of tossing, number of throwing, or number of items, all will come under this N representation. So we can use generally this formula. Usually while solving the problems, we are using this notation. That is, instead of R, we are taking as X. So even we are going to solve the problems, or through this lecture also completely, we are using the notation NCX P power X Q power N minus X. The clear picture, P is nothing but probability of success. Probability of success. The meaning is, before tossing the coin, my expectation, I want head. If I get head, probability of success. Not getting, probability of failure. How many times? Decided to toss 5 times. So N is playing the role 5. Then what about this X? X is the specific target. And one more thing we have to keep in our mind very strongly, that X is taking the value from 0 to 0, 1, 2 up to N. It is finite. Q is nothing but 1 minus P. So now the problems are there. Suppose in case we want to solve the problem. In the problems, it won't be given. This problem comes under binomial distribution or Poisson or normal distribution. We must be in a position to identify the given problem comes under whether binomial or more other distributions are there, Poisson or normal. For that, binomial distribution means what are the conditions it should satisfy. So now here the one die is given. We know it. So the die is there. The die, it has 6 faces. If you throw a die, we will be getting the possibilities of 1 or 2 or 3, 4, 5, 6. Maximum out of which we will be getting any one value. So these are the possibilities we will be getting if we throw a die, a single die. Now, the trials are repeated under identical conditions for a fixed number of times. The N, the binomial distribution, is finite. That we have to remember. Next, there are only 2 possibilities. That is, I want to get, if I throw a die 3, I'm throwing, I got it 6. So failure. My expectation is 3, but I got it 6. So I got failure. So only 2 possibilities, yes or no, according to your satisfaction. 3 I expected, but I got it 6. So no, or failure, or false. So true or false, yes or no, success or failure. Like that, answers will be coming if you adopt the binomial distribution while solving the problem. So it is given very clearly that there are only 2 possible outcomes, example success or failure for each trial. The third one is the probability of success in each trial remains constant and does not change from trial to trial. Now, First I'm throwing this die. I got it 1. The probability of getting this 1 is the basic definition of probability. My expectation is I want 1. Favoring 1. How many sample point? Only 1 divided by total sample point. So 1 by 6 is the probability of this getting the outcome 1. Second time also I am getting the same 1. Again 1 by 6 only. It won't change. Or 3 I am getting the probability 1 by 6. So satisfying the basic definition of probability. So the last one is the trials are independent. That is, the probability of event in any trials is not affected by the results. Now 6, it has to come on its own way. If we throw the die, it will come. Or 5, on its way, it will fall. No one. They are independent. There is no force. Yeah. Now, we completed the definition of binomial distribution. That is, this is the binomial distribution formula. NC p power x q power n minus x. N, total number of throws or tossing or total product. P, probability of success. What is the condition which is given in the problem that we accepting? That is probability of success. Probability of failure, opposite to P. N, we got it. X is a specific target. Now, mean of the binomial distribution we will derive now. If capital X is the random variable having the binomial distribution with parameters n and p, we know it what is n and what is p. That is, n is nothing but number of throws, number of tossing or number of the products. P, probability of success. The mean of a binomial variate. The capital X is playing the role of random variable. Random variable, the work what it has, it is a real valued function. That is, the sample points are converted into real numbers. Mu equal to NP. That is, the mean of the binomial distribution is NP. And variance of the binomial distribution is NPQ. Here, the mu, the symbol stands for mean. Sigma square, it stands for variance. Now, mu equal to NP, sigma square equal to NPQ. The same question, this is the theory, the statement of the theorem. It can be asked this way, either this way or this way also it can be asked. That is, prove that mean and variance of binomial distribution is mu equal to NP and sigma square equal to NPQ. Either this or this, that way can be asked. Now, the general formula. So we will prove it now, the mean of binomial distribution. The proof is the general formula for mean, mu equal to summation x equal to 0 to n, x into p of x. Now, this p of x is nothing but, now we are concentrating binomial distribution. So we are going to replace this p of x by binomial distribution formula, that is this formula. Suppose the question is mean of Poisson distribution, then p of x is replaced by Poisson distribution. Now we are concentrating this lecture binomial distribution, that is the reason p of x is replaced by binomial distribution formula. So, everything is written as it is. Only the p of x is replaced by binomial distribution. So the binomial distribution formula is written. So now here this are factorial notations. Now 5 factorial. So 5 factorial, then we'll start from 5. 5 into 4 into 3 into 2 into 1. Next the same 5 factorial, 5 into 4 into up to 1 we can write. Otherwise 5 into 4 into, in middle only we are stopping. Then 3, it should retain the factorial symbol. That we have to remember. Now suppose 6 factorial is there. We can write 6 into 5 into 4 into 3 into 2 into 1. The same 6 factorial, 6 into 5 into, I want to stop up to 4. Yeah, we will stop it. Nothing wrong in it. But keep the factorial symbol. Otherwise, up to 1 we have to go. It's a very simple concept we have to keep in our mind. Because this is going to play a role, very important role while deriving this mean and variance of binomial distribution. Now n factorial, they are numbers first, the examples are given. Now n factorial, n, the next one 1 less. Here this 6 factorial is there, 6. The next is 1 less. The next is 1 less. The next 1 less, 1 less up to 1 we rotate. Same here, n factorial, n first. The next 1 less, n minus 1, we stopped it. So n minus 1 factorial. In case we want to continue, n into n minus 1 into, yeah, we will continue, n minus 2 factorial. So it goes on. Suppose next term it will be n minus 3 factorial. This is the way the factorial notation is expanded. So now it is written here, n factorial equal to n into n minus 1 into n minus 2 factorial. Here, so summation x equal to 0 to n, x into binomial distribution. Now, this binomial distribution formula, it's nothing but ncx p power x q power n minus x. Now, this step and this step, we will do the comparison. Everything we wrote as it is written. There is no changes at all. But only one place the change it is there, that is ncx. The ncx is replaced by ncx, replaced by this position, what is there, n factorial, divided by this position, what is there, x is there, x factorial, and these two we have to do the subtraction, n minus x factorial. This is the formula for ncx that is written here in this particular place. So you can see it very clearly. So this is clearly, it is, we replaced ncx by n factorial by x factorial into n minus x factorial. The same, everything is written as it is. A small change we have done it. That is, the previous step x equal to 0 to n. But in this step, x equal to 1 to n is there. Why we neglected that 0? What is the reason for that? The simple reason, we are substituting 0. So which place? X place, because x is taking the value from 0 to n. That is the meaning. The summation. The symbol is summation. sum x from 0 to n. We will first x plus we will put 0. So here we are substituting 0. 0 into anything 0. So the summation value when it is 0, the entire thing is vanished. Then why we have to concentrate on this 0? Better we will neglect it. We neglect it. So 0 is neglected. We removed it. Then we are starting the summation from x equal to 1 to n. This is the reason behind that. Next. Here everything. Here same. And n factorial is written. And this term also as it is. Only we brought the changes. This is also as it is. We brought only the changes x factorial. Here only the changes. So remaining this step and this step we are doing the comparison. We did the changes x factorial by x into x minus 1 factorial. We did the change. Okay, fine. Here the formula is n factorial. That is n into n minus 1 into n minus 2 factorial. Here n is there. Here x factorial is there. So x factorial can be written as x into x minus 1 factorial. The question will be asked, why to stop exactly x minus 1 factorial? Why it can be written x minus 2 factorial also? No, or we can expand up to x minus 3 factorial also. Why? What is the specific reason we have to stop up to x minus 1 factorial? Only the answer it is possible to give. Already binomial distribution. The mean of binomial distribution is NP we have to prove. To prove that one, these are the steps are followed. So following these steps, we have to bring this mu equal to this entire term. Some modifications, some mathematical laws or some simplifications we have to apply, and we have to bring this right side entirely. The answer it should become NP. That is only our main target. Okay, fine. Now here x minus 1 the factorial, this is replaced. Now the next step, this x we removed it. So after removing x and x, this is the simplified form. Yeah. The next step again, this n factorial we simplified n into n minus 1 factorial, because we know it n factorial, n into the next term 1 is less, n minus 1 factorial. That it is substituted in this place. Fine. The next step, this n is there, that we brought it front. Remaining everything we wrote it as it is. No changes at all. The next step, so what are the changes, steps we are following? That is the most important thing while deriving the binomial distribution. Not only binomial distribution, any mathematical theorems we are solving, in middle we will assume our assumptions or simplifications as a keynote we have to keep in our memory space. It is very compulsory. Otherwise, we can't reach the target. Here, our target is to reach mu equal to NP. That is our target. So, the next step, if you are noticing, N here, everything as it is, we wrote it. Complete. But this is also, but this term extra we added, that is p power plus 1 into p power minus 1. That is p into p power minus 1. This multiplication we have taken. Suddenly, if we have taken, it won't affect the result, or mathematically is there any law? Yeah, mathematically there is a law. P power plus 1 into p power minus what we included here. But we know it, the exponential law, a power m into a power minus m equal to a power m minus n equal to a power 0, which is equal to 1. For following that, so p power 1 minus 1 0 equal to 1. So 1 is the multiplicative identity. It won't affect the result. So that is the reason, obeying the mathematical law, we can put this term here, nothing wrong in it. To bring the answer, mu equal to np we have to bring. Yeah, next. In this, p power plus 1 is there. So p power plus 1, otherwise p. If nothing is there, we know it, the default, the up it is plus 1 is there. So this p power plus 1, we brought it the next step, n into p we made it. So the remaining all everything, this one, here, this one, this, here, and this one. So the p power x as it is, this p power plus 1 only, it has the next step before the summation we kept it. So p power minus 1 as it is written. So this p power x into p power minus 1, it's nothing but the exponential law. Obeying that, we can write it p power x minus 1. So very the clear picture it is given. Now, these are the small formulas which we studied in our lower classes. That is, a plus b the whole square formula. That is, a square plus 2ab plus b square, and a plus b the whole cube, the formula, a cube plus 3a square b plus 3ab square plus b cube. Why suddenly these formulas are coming into picture here? Yeah, there is a reason. Now, this is the last step up to the previous slide. It is kept here. Fine. Now, we are going to apply, that is, x is going to take the value from 1 to n. First, we will substitute, wherever x, we will substitute 1. Yeah, fine. We are going to substitute now in the place of x. So n minus, the top one is n minus 1 factorial divided by, here the x place we are substituting 1, 1 minus 1, 0 factorial. Fine. N minus 1 factorial. Good. P power x minus 1, that is 1 minus 1. Q power n minus 1. This both are getting cancelled. We know it 0 factorial, the value is 1. So this is becoming the value is 1. P power 0, the exponential law, a power 0 equal to 1. That is the reason p power 0 is also 1. Yeah, fine. Here also 1. So q power n minus 1. Everything we simplified. The leftover we are getting q power n minus 1. If you substitute in this, x is taking the value 1. We are getting, this is the answer. We will see it. Yeah. This as it is. We substituted x equal to 1. We got it q power n minus 1. So the next one job we completed. Next we will substitute x equal to 2. We will substitute. So now x is taking the value 2 n minus 1 factorial divided by, here 2 minus 1 factorial n minus 2 factorial p power 2 minus 1 q power n minus 2. Fine. Here 2 minus 1 factorial. It's nothing but 1 factorial. This n minus 1 factorial, we can simplify n minus 1 into n minus 2 factorial divided by 1 factorial, that is 1. 1 factorial value also 1. 0 factorial value also 1. Fine. So the down is n minus 2 factorial p power 1 into q power n minus 2. This getting cancelled. We got the second term also correctly. Next, we have to substitute. This is when we substituted x equal to 1, we got it. This, when x equal to 2, we substituted, we got correctly. The next we have to move x equal to 3, 4. Better, we will go to the last term. This is actually some sort of a small technique. It's my personal opinion. Got it? That is a plus b the whole square is there. Here how many variables are there? 2 variables are there. A and b. The 2 variables highest power is what? 2. So if we are writing a plus b the whole square, simple logic, simple technique it is there in that formula. Here also a cube plus 3a square b plus 3a b square plus b cube. How many variables are playing the role? 2 variables, a and b. A highest power is what? 3. B highest power is what? 3. So a plus b the whole cube. This formula we are studying from lower class onwards, 6th class onwards. This formula is playing a role. It is playing a journey with us. Now the same journey, that small technique, we will use it here. That is, here the last one, the highest power is n. So we are using the n, we are substituting here the last one q, n minus n. So q power 0, it is becoming 1. And this is p power n minus 1. The term it is written, the last term. So this np, how we are writing a plus b the whole square. In this a and b, they have the highest power, keeping in the mind a plus b the whole square, that we are accepting, and a cube plus 3a square b plus 3a b square plus b cube. Here the 2 variables a and b are there, and this a and b also having the highest power 3, then a plus b the whole cube we are accepting. Why not here? The same, here p and q2 are there. So p plus q the whole power. P power is n minus 1. Q power is n minus 1. Better we can write it here also. P plus q the whole power n minus 1. Mathematically it is obeying the law. So whatever the theoretical, the distribution which obey the mathematical law, we can accept it. So now NP as it is, P plus Q, our P is probability of success, Q probability of failure. Always the total probability is 1. So 1 power n minus 1. So we proved it, mu equal to NP. So the initially we have taken summation x equal to 0 to n x p of x we have taken. Then the p of x is replaced by our binomial distribution. So many simplifications we did. And the main thing, p power plus 1 into p power minus 1. This keynote we should not forget. And the last step, this is also we should not forget. If you forget, we cannot reach the answer. So it is already, we discussed in detail about mean of the binomial distribution. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.